This is video 4 for the statics unit. Now, as I mentioned before, a force comes from an interaction between two objects. So this leads us to like an action-reaction scenario. So if one object exerts on a force, or exerts a force on a second object, the second object exerts a force that is equal in strength on the first object but opposite in direction. And again, this is because a force is an interaction between two objects. So they always exist in pairs. We call these interaction pairs. When you push on a door, the door pushes back on you with the same strength of force. Now what's different is that you and the door have different masses. So that's why you're still able to push the door open. So here we have a girl pushing on a wall. So the girl applies a force on the wall, and the wall applies a force on the girl. And note that each of these forces are acting on different objects, and also they're within the same system. So these interaction pairs are actually internal forces in a system. And that's always true. So we're bringing back the term for system. Now, I do have a warning. Do not assume that interaction pair are involved every time you see two forces happen to be equal in strength and opposite in direction. You will encounter several situations where you'll see two forces that are equal in strength, opposite in direction. But the difference is that they're acting on a single object. They cannot be an interaction pair because they're acting on the same object. Remember, interaction pairs are internal forces in a system. So interaction pairs or interaction partner forces act on different objects. So here, what we have is a girl wall system. And then these two forces, these interaction forces, are internal forces inside this girl wall system. Let's take a look at another system. Here, I have another system. This is the hammer nail system. So the internal forces then, when this hammer strikes the nail, we would have a force of the hammer on the nail, and then the nail will exert a force that is equal in strength on the hammer. So these two forces are within the hammer-nail system. And you may be wondering, well, if the hammer exerts a force on the nail and the nail exerts a force on the hammer that is equal in strength, wouldn't those two forces cancel out? But the answer is no, they will not. Because this force, the hammer on the nail, then just has to overcome the friction in the wood. And this nail on the hammer, there's really no other forces except maybe a contact force from the person's hand that you have to worry about. So no, those two forces would not cancel out. Let's take a look at this right here. Notice that these two forces are equal in strength, opposite in direction, the force due to gravity and the normal force. However, this is not a system. It's not a system. So those two forces are not interaction partners. They're not interaction pairs. So how can I rectify this? Well, if I were to take a look at a bigger system. Let's say if I were to take a look at the box table system. Then we would see something. Because this box is exerting a force, a contact force, on the table. So the table is exerting a force, which was called the normal force, on the box. So this would be box on table. And then this normal force would be the table on the box. Now we have a system, and now we have a pair of forces that are interaction pairs. All right, this was a shorter one, but this concludes our static units notes.